Okay. The one of the one of the really amazing developments in the last century or so has been um, the the development or the construction or the design, I guess I should say, of systems to purify drinking water and to also clean up our wastewater. And it's those two things together that have just made enormous improvements in drinking water, in surface water quality. So let's talk a little bit about where the water. It's sort of a cycle, but we can think about. Let's think about drinking water first. Drinking water purification. So where does water come from? Well, water comes generally from either from rivers that's used in drinking. Usually comes from rivers or aquifers, right? And in either case, we have to make sure that the water is potable. It's able to be consumed without making us sick. But we also want to make sure that the water is pleasant to taste, if at all possible, and it's not going to wreck our showers or stain our sinks or whatever. So um, let's just think about the way the sort of a generic. There are lots of variations on a theme here, but a really generic system would operate something like this. So we have a water, we have a river, and we've got a wastewater, excuse me, a drinking water plant here. And the drinking water plant may have wells going down into the ground. It may have pipes that go down into the river. It may use both. The one in Iowa City where I live actually uses both. They have a series of different wells, some shallow, some deep, and some that go into the river. And they use the water depending on what time of year it is and what their demand is. So in Iowa City, for example, they have what's called an alluvial aquifer. Alluvium is the material that's deposited by a river or stream. So this is generally sands and gravels in here. And the water in the alluvial aquifer is basically the water that's coming out of the river, right? So that's what's recharging this aquifer. So you can either take the water directly out of the river, or you can take the water from over here out of this alluvial aquifer, which is river water. But as it's migrated over days or weeks over to this well, it's been purified a little bit, right? Organisms living in the material, in the sediment, can help break down some of the things like nitrate and viruses and different pathogens might die en route or be killed en route. And so it's generally cleaner over here. But if you want to drill a really deep well, now you're going down into the limestone, and this is water that's been underground for much longer. The water that shows up in the limestones that are 1,000, 1,200 feet below the land surface in Iowa fell as rain or snow up in Minnesota thousands of years ago. So this is a much cleaner variety, but there's much less of it. So in general, there's sort of a balancing act that goes on in Iowa City to make sure that they have enough water to meet their demands. So what happens when the water comes into this wastewater treatment plant? The water comes in, and it's got to be processed somehow. So they do a couple of things, right? So one thing that might be done is they literally will put it in a blower. So the water, those huge amounts of air being blown up like this, and the water is poured over the top of it. And as the water soaks through this blower, it kind of gets turned into like a mist, and gases that are dissolved in the water that we might not want, like our old friend radon, or hydrogen sulfide gas, which smells like rotten egg. Radon is radioactive. It's a radioactive gas. And hydrogen sulfide can be found in water associated with some rocks, and it just smells bad. So both of those gases are going to be a lot of them are going to be kind of lost in the water as it comes through this blower. Will be considerably cleaner and safer. But there's still other stuff in there that we want to get rid of, right? So let's assume that there are no nasty pesticides or contaminants, so it's otherwise pretty clean water. One common problem is that it may have a lot of iron. And iron is not a problem. You can drink very, very iron-rich water without any kind of detrimental health effects. But it does cause your pipes to clog up, and it does cause iron stains in your faucets and that sort of thing, and people generally don't like it. So how do you get rid of the iron? Well, iron's a metal, and metals are generally less soluble at higher pH. So if you raise the pH up way above the normal values that you'd expect for water, like way above 7 or 8, the iron, any iron that's dissolved in the water, will precipitate. And so they have these big tanks, these big circular tanks with a sort of a drain at the bottom, and the water comes in, and they add to it some sort of something like sodium hydroxide, some sort of base. And what this sodium hydroxide does when it mixes in with the water is it raises the pH of the water, and any iron that's dissolved in the water will literally precipitate out. It looks kind of like snow, and it'll settle to the bottom and be taken out of the system. So now you've got water that's much cleaner. The water then often will go to a chlorination station. And what chlorine will do is it kills pathogens. You can either do chlorine, or in some cases, which we talked about the other day, you can use ultraviolet light. The nice thing about chlorine is that once it's in the water, it doesn't go away, unlike ultraviolet light, where you kill anything that's in the water, but then as the water moves on, if another pathogen gets in, it can live. Chlorine, as long as it's in the water, will continue to kill these organisms. And from then it gets shipped generally to the water tower, wherever that is. You have these big water towers. They hold lots of water up there. And then the water, comes down out of its own pressure. It's got a big hydraulic head whenever you need it. You don't have to constantly having pumps going all the time. What about wastewater plants? Wastewater plants are a little bit different, right? So from our homes, so wastewater treatment plants. From our homes, we have water that comes out of the sinks and out of the toilets and the showers. And that water gets directed in sewers. Ideally, nice new sewers, so there's not a lot of leakage and everything, but the sewers collect this stuff from the houses and the factories and the office buildings all over town, takes it to a wastewater treatment plant. And the idea is that the water that comes into the wastewater treatment plant is quite dirty, and by the time it comes out, it's clean enough that it can be emptied right into a stream. To empty to a stream without causing any kind of environmental damage. And the stream water mixes and dilutes the effluent, the wastewater. And, what happens, what one community discharges into the stream gets taken up by another community further downstream, and they process it and use it for their drinking water. It's just this constant cycle. So what happens to wastewater once it enters a facility? Basically, there's a series of steps, and again, it's all variations on a theme, but generally the water comes in and it goes into goes through a screen. There's some sort of screen that takes out all kinds of strange things that get washed down the sink or flushed down the toilet. Some kid flushes a goldfish, or there's a Barbie doll, or nuts and bolts, or screw, whatever, all that kind of stuff gets collected there. And then the water comes out, and it goes into what's called a grit tank. A grit tank, where things that are small enough to fit through the screen, like bits of gravel and whatever else, will settle out to the bottom and be pulled away, carted away. And then after that, the water goes into a digester. And digesters, there are often a couple of these in sequence. Basically what they are is they're big microbe factories. So they're just tons and tons of microorganisms in here. So many that the water appears brown, but it's not things like the stuff that, it's not your poop and everything that's making it all brown. It's mostly these microorganisms. And there's tons and tons of these things living in there, and they are aerobic. They need oxygen. They've got all the food they can eat in the organic matter that's in these tanks that's come from the sewers, but they don't have enough oxygen. So we bubble oxygen in there, and so that it looks like a rapids or something. It's like bubbling up, and all that is oxygen. And the oxygen then allows these organisms to just grow like crazy. They've got all the food they want, they've got all the oxygen they need, and they break down the organic material. They eat it. The water, after it's been in here for a while, goes typically to a second digester where it's purified the same way, even further. Second digester. And out of that, it goes to what's called a clarifying tank, a clarifier, where the water comes in, and unlike the kind of roiling water filled with oxygen and all kinds of stuff, this is just like a nice, calm, placid little spot. And any of the microorganisms that get in here that were in these digester tanks have a chance to just slowly settle out to the bottom, or they float. And if they float, they get skimmed off the top. So the floaters are skimmed off the top, and the settlers are pumped from the bottom back to the digesters. And the water that comes out of these clarifying tanks is very, very clear. It's clear and pretty clean. The one thing that we haven't taken care of in this system are things like viruses. And we don't want viruses that have come in from somebody, somebody who's infected with some disease, to be releasing that stuff back into the water supply. So from these clarifiers, then the water goes either through a chlorination step or a ultraviolet light step to kill the viruses and that sort of thing. And from there, it goes back to a stream, and that's it. And that is our drinking water. It's really quite simple and elegant. Once in the stream, as I said before, it gets diluted. But in some places that are suffering from severe droughts, they are literally closing the loop. So when water goes from a wastewater plant, it literally gets pumped without stopping right back to the drinking water plant. And this is happening in Texas and in the Southwest, where they're just running out of water. And so in an ideal world, what you do is you just close this loop, right? And all of the water that goes into the drinking plant comes from the wastewater, and all the stuff that goes down our drains, which comes from the drinking water, goes back to the wastewater, and it's a loop. In reality, they're doing stuff like 10% maybe of the water comes from the wastewater plant, 90% or so comes from wells. But by doing this system, you have, it's like 10% reduction or maybe a 20% reduction of water that you have to pull out of the wells. And so you're able to allow the aquifers to last a lot longer, or the rivers to be less taxed. And, it sounds a little counterintuitive, it might even sound a little bit gross, but the idea here is that the efficiency of these wastewater treatment systems is so high, and they're so effective at doing what they're supposed to do, that you literally can put the water right back into a drinking water system. Now, the only other thing you have to do, of course, along the way is you need to test. You need to test particularly the drinking water to make sure, but also the wastewater, to make sure that it's meeting local, but mostly state and federal guidelines. federal standards. You can't just run water through a wastewater plant and then dump it out regardless. You have to test and you have to show that you're meeting the standards of purity that the Safe Drinking Water Act and so forth and the Clean Water Act provide for.